Okay, so this is the 2024 Higher Level Applied Maths Leaving Cert Paper Question 6. A statistician is monitoring the population of a small island. Due to the birth rate being greater than the death rate, the population of the island naturally increases by 1.2% per year. However, a fixed number of people, X, emigrate from the island every year. The statistician develops a difference equation to model Pn, the population at the beginning of the year n. The model assumes that immigration occurs at the end of each year. At the start of year 2022, there were 13,500 people on the island. That is, P0 is equal to 13,500. Write down a difference equation to express Pn plus 1 in terms of Pn and x, where n is positive or equal to 0 and n is an integer. So we need to write down Pn plus 1 is equal to, we've got to increase the previous year by 1.2%, so that's going to be 1.012. so this is your 1.2% and this is your 100% if you like. So you're increasing it by 1.2%, and that is of the previous year, which is Pn, and then we've got to subtract the number who emigrate, which is x. That's it for part 1. Okay, so solve this differential equation to find an expression for Pn in terms of n and x. So we started with Pn plus 1 is equal to 1.012 Pn minus x. What I'm going to do is have a look at P0, P1, P2 and P3 and determine a pattern. So if we start with P0, we were told in the question that P0 is 13500. Let's have a look at P1. Well, P1 is going to be equal to 1.012 times P0 minus x. Remember, you've got an n here, you've got an n plus 1 here. So this is going to be 1 less than this. So P1 is equal to 1.012 times P0, which is 13,500 minus x. Let's have a look at P2. P2 is going to be equal to 1.012 times P1 minus x. Now we know that P1 is this expression here, so let's put that in. It's 1.012 times 13500 minus x, and then we've got this minus x as well, so we put that out here. Just to simplify that, we've got 1.01 squared, 12 squared, times 13500 minus 1.012x minus x. Okay, so let's have a look at P3. P3 is going to be equal to 1.012 times P2 minus x. So P2 is this thing here, so let's put that in. So it's 1.012 times 1.012 squared, 13500 minus 1.012x minus x, and then finally this minus x comes out here as well. So let's just multiply all this out. So these two here will give me 1.012 cubed times 13500 minus 1.012 squared times x minus 1.012x minus x. Okay, so that's as much as I'm going to do. I'm going to just look at Pn now. Looking at this, you can see that there is a pattern here. You've got 1.012, this is a 3, this is a 3, so this is an n, this is going to be an n here. You've always got a 13500, and then you've got all of this as well. So I'm going to put this separately in a bracket. I'm going to put minus here, and I'm going to start with the lowest power here, which is 1.012 to the power of 0, if you like. So I'm going to start with this one, then this one. So it's going to be plus, because minus times plus gives you a minus. So it's going to be minus 1.012x, and that's to the power of 1 here, plus 1.012 squared x, plus all the way up to 1.012, let's move this over a little bit, up to n minus 1 times x. That's because if you look at this here, this is always 1 less than the n value here. So it goes from x up to 1.012 to the power of n minus 1. Okay, so this is what I'm going to try and simplify then. So we've got 1.012 to the power of n, 13500 minus, I'm going to factorize out this x, which will give me 1 plus 1.012 plus 1.012 squared plus all the way up to 1.012 to the power of n minus 1. Now what you probably noticed then, inside that bracket you've got a geometric series, this bracket here. So I'm just going to add that using the sum of a geometric series. There are n terms because you've got 1 here, you've got 2 here, and so on, and then n minus 1 here, but you've got this extra term here. So there are n terms. The first term is 1, so a is 1, so it's one bracket. I'm going to put or first, so it's or to the power of n. So our or is 1.012 to the power of n minus 1. Then that's all over 1.012, our or minus 1. So that formula is in your tables anyway. So it's a times r to the power of n minus 1 over r minus 1. So all we've got to do is just simplify this now. Let's do that. So we have 1.012 to the power of n, 13500 minus x times 1.012 to the power of n minus 1 all over 0.012. Now on the next line what I'm going to do is I'm going to just divide this into the 1 here. There's a 1 here. This is just a fraction here multiplied by a fraction. So what I'm going to do is divide this into this 1 here. Okay, so we've got 1.012 to the power of n, 13500 minus, now when you divide that into 1, so 1 divided by 0.012, you'll get 3, so you'll get 250 over 3 times x, and then in the bracket you're left with 1.012 to the power of n minus 1. So the next thing I'm going to do is just multiply out this bracket here. So it's 1.012 to the power of n, 13500, minus 250 over 3x times 1.012 to the power of n minus, plus actually, because it's minus times minus, which is plus, so it's 250 over 3x. So the last thing I'm going to do is you've got a 1.012 to the power of n, 1.012 to the power of n, so I'm just going to factorize that out of those two terms. So it's 1.012 to the power of n. Here I'm left with 13500 minus, and then just this expression here, 250 over 3x. And then out here I'm left with 250 over 3x as well. So that's really it for part 2. That's as much as I'm going to do with that one. Okay, so let's have a look at the next one. We have part 3 here. At the start of the year 2023, there were 13,514 people on the island. That is, P1 is equal to 13,514. Calculate the value of x. Okay, so let's just write down our equation again. So we got Pn plus 1 is equal to 1.012 times Pn. This is Pn plus 1. That's minus x. So we know that P0 is equal to 13,500. So now we know that P1 is 13,514, and that's equal to 1.012 times 13,500 minus x. All you've got to do is solve for x here. So look, I'm just going to do this. It's just x is equal to 148. So all you got to do is subtract this from both sides and then change the signs. You'll get x is equal to 148. And that's it for part 3. So let's have a look at part 4. So calculate the predicted population at the start of the year 2029. So I've written in the formula that we derived earlier on for Pn. We solved the difference equation, we got this here. So we're talking about 7 years between 2022 and the start of 2029. So we have to include 2022, and it's the end of 2028 if you like. So we're going to put in 7 here, so it's P7 is equal to 1.012 to the power of 7 13500 minus 250 over 3. We worked out x as well as 148, so we can put that in there. And then plus 250 over 3 times 148. Look, that's all just calculator work, so I'm not going to go through all of that. You can do that yourselves. But you end up with 13601.5 and so on. So I'm going to round that up to 13602. So this is my answer here. 13602, that's going to be the population at the start of the year 2029. Let's look at B. The acceleration of a particle moving in a straight line may be expressed in terms of its velocity v in meters per second and its displacement s in meters by the differential equation v dv ds is equal to e to the power v squared over 4. Solve the differential equation to find an expression for v in terms of s, given that v is 0 when s is 0. So if we write down v dv ds is equal to e to the power of v squared over 4. We'll just separate everything out. Let's see, we have v times e to the power of minus v squared over 4 dv is equal to ds. So what I did there was I took the ds and brought it up here, and then I took the e to the power of v squared over 4, divided it so it ended up down here, and then just brought it up by raising the power to minus v squared over 4. So the way we've got to do this is, I think, by substitution. Substitution, I think, might be the easiest way to do this. So I'm going to say let u equal to minus v squared over 4. Differentiate du dv is equal to minus half v. Because you bring the 2 down, you get 2 over 4, which is a half. So what I'm going to do now is I need to try and get rid of this v here when I integrate. So I want this v here to be on the bottom. So if I multiply across or bring the dv over, I'll get du is equal to minus a half v dv, and then divide by v, so that'll give me du over v, multiplied by the 2 as well, so the 2 will end up here, and then bring the minus over as well, that'll give me dv here. Okay, so this should work because I'll end up with, instead of this dv here, I'll end up with this here, which will have a v on the bottom, which will cancel with this v here. So that'll make life a lot easier, I think. We've got to integrate this, by the way, here and here. Let's put in the limits. So the limits are going to be 0. We're going to start at 0. We're going up to some v. We're starting at 0. We're going up to some s here. So we want to integrate from 0 to v e to the power of u, because remember u is minus v squared over 4, and then dv is this thing here. So we got to multiply by minus 2 du, well I'll just put the du outside, I think, minus 2 over v, and then du out here. And that's all equal to the integral from 0 to s of ds. Okay, so let's just simplify all of this. So what I'm going to do first is, I have this minus 2 multiplied here, so I'm going to bring that outside the integral. And I've got 0v here, or yeah, 0v. And then what I've got here is I've got a v on the bottom, a v on the top here, so that's very handy. And I'm simply left with e to the power of u du on the left hand side, so that simplifies everything. If I integrate 1 ds here, I'll just get s, and the limits here are 0 to s. So now I've got minus 2, and I've got to integrate e to the power of u, which is just going to be e to the power of u, 0 to v, and then on the right hand side I've got to put in s and minus 0 if you like here. Okay, so let's just change that u, so it's minus 2 e to the power of, remember u was minus v squared over 4. And we're going from 0 to v, and over here we've just got s, so let's put in our limits now. So we've got minus 2, and then we've got e to the power of minus v squared over 4 minus e to the power of, if I put a 0 in here, I'll just get e to the power of 0, and that's equal to s. I'm just going to come up here now to finish it off. So we have, let's see, we have minus 2e to the power of minus v squared over 4 minus 2 is equal to s. Because we've got to multiply this by this, it's actually plus 2. So minus 2 times minus e to the power of 0, or minus 1 if you like, is plus 2. So what I've got to do here is try and get the v on its own. So I'm going to bring the 2 over, I'm going to bring this 2 over, and I'm going to divide by minus 2. So it'll leave me with e to the power of minus v squared over 4 on this side. Now on this side here, I'll start off with s minus 2 over minus 2. I'm just going to change the signs top and bottom. So what I'll end up with here is 2 minus s over 2. Okay, so now I just need to get the log of both sides, the natural log of both sides. So minus v squared over 4 is going to be equal to the log of 2 minus s over 2. I'm going to multiply across by 4, change the sign because of this minus, and square root both sides. So that'll give me v is finally equal to minus, multiply by 4, log 2 minus s over 2. That's my answer there. Okay, so in part 2, calculate the velocity of the particle when s is equal to 0.3. So I've just done that out here. This is the formula that we got in the previous section for velocity. So all you got to do is, instead of s here, stick in 0.3 and just do it on your calculator and you'll get this value here. Okay, so that's it for this question.